So we have three type of notations for representing the algebraic expressions, starting with the infix notation, another one is the postfix notation, another one the prefix notations. Okay, so these are the three equivalent notations for writing the algebraic expression. But in day-to-day life, we utilizes the infix notation for writing the algebraic expressions. Like we have the expression, like it is given here a plus b. So why it is the infix expression and why we are like saying what is the difference in between the infix notation, postfix notation, and prefix notation. So let me tell you first the what is the infix notation basically is. So we have suppose two operands a and b, and I want to perform the addition operation. Then I will just put the addition operator in between them. Okay, as the operator is coming in between the both operand, that's why it is known as the infix expression. Okay, so the infix expressions like basically very easy to write. Okay, and but the computer find it difficult to parse when it is doing the parsing of the infix expression, because the computer need to like store a lot of information to evaluate the expression. What is that basically? That particular information, that is the operator precedence, that is the associativity rules. Okay, and the brackets, we need to check the bracket in the expression. So what is the operator precedence? Like we have several operations in an expression, like we have a plus b multiply c. So we have three operations here. So the operator precedence, this is the multiplication having the higher precedence, so it will be solved first before the this particular addition operation. Okay, so the computer need to like store this particular information related to this. Suppose the expression is this, like I'm just writing here a plus b multiply c. Okay, sorry, a plus b plus c. So now we have two operators with the same precedence. So when the two operators are there with the same precedence, then we need to go with the associativity rules. Like the operator which come first, which that will be evaluated first. Okay, and third one is the like brackets. So brackets are that powerful thing which override all the rules of the precedence and the associativity. Okay, so the computer work like basically more efficiently with the expressions written in prefix and postfix notation rather than the infix notation. So let's see, like if I want to perform the addition operation, then I will write the operation in between the operand. If I want to multiply the two operand, then I will write the multiplication operator here like this. Okay, so operator plus and asterisk or the multiplication go in between the operands a and b. So this is the infix notation. Let's see what is the postfix notation. So the postfix notation basically was given by the mathematician Jean Lacashwitz, who was a polished logician, mathematician, and philosopher. So like he want basically like he want the expression with the without parenthesis basically. Like his aim was to develop a parenthesis free prefix notation, also known as the polished notation. Okay, I will just tell you in the next slide what is the prefix notation and how we can represent the expression in this particular notation. Okay, and the other one is the postfix notation, which is better known as the reverse polished notation basically. Okay, so in the postfix notation, like suppose I have two operands a and b, and I want to perform the addition operation, then what I will do, I will write the operand 1, operand 2, and I will place the operator in before the operand. Like it will just look like plus a b. So this is known as the prefix notation basically. Okay, and if I am just I want to perform addition operation, suppose, so I have two operands a and b, and if just I will just place the operator after them a b plus like this, then this is known as the postfix notation. Okay, so let's see something in details. Like in the postfix notation, this is the another alternative, that is to put the operators after the operand as like this, like a b plus or a b star. Okay, so what is the important thing that we are just looking here? The important thing is like when we just go for the evaluation of the postfix expressions, then we will just go from left to right, and the system and all ourselves, we need not to store any such special information like what is the precedence of the operator, because okay, like we need to just go from left to right, and the whatever the operator comes first, that we will evaluate using the operand. and there is no need to check for the associativity, there is no need to check for the brackets here. Okay, so this is the postfix notation. Now the prefix notation I have already just explained you in the previous slide. If suppose I have two operands A and B and I want to perform the multiplication operation, then what is the sequence here? I will write the operand 1, operand 2, and I will just place the operator. Suppose the operator is the plus. So here we have the operand 1A, operand B, operand second operand B, and I will just place the operator here. Okay, so this is known as the prefix notation basically. Okay, so also the prefix expression do not follow the rules of operator precedence and associativity, and even brackets cannot alter the order of evaluation, as same with the postfix expression. Okay, so this is the prefix expression plus AB. For the multiplication of AB, we'll just write it multiply AB. So this is the prefix notation. Okay. So the term infix, prefix and postfix like tell us whether the operator go between before or the after the operand. So I will just tell you, like, just give me 1 minute basically. So suppose I have two operands here, A and B. So in the infix expression or in the infix notation, infix, and second one suppose is the prefix, and third one is the postfix. Suppose, okay, so I'm just taking this sequence here, and I have the operators with me AB and here AB. So in the infix notation, in, just focus on this, in means between, so the operator come in between the operand A plus B. In the prefix notation, pre means the operator come before the operand, means operator first operand second operand, and the postfix means first operand second operand, and the operator means after the operand. So this is the like way we can just distinguish between the infix expression, postfix expression, and prefix expression basically. Okay, so hope it is like the basic distinction in between the prefix expression, infix expression, and postfix expression is, like, I think, clear to all. Okay, like this is the we have two operands A B. For infix, operator come in between. For prefix, operator come before the operand, and for postfix, operator come after the operand. Okay, and suppose when we are evaluating the, what are the different things that we need to consider in case of the infix expression basically. Suppose I want to perform the addition operation. I have the expression here, sorry, I have the expression here, 2 plus 3 multiply 5. So in this particular infix expression, uh, I have three operands, 2, 3, 5, and I have two operator 3 and multiply. So as I have two operator, and then I need to check the precedence, like which operation should be performed first. So the multiplication operations have precedence over the addition operation. So first this multiplication operation will be performed. So it will be like 2 plus 3 into 5, that is 15. Now we have only one operand, so just we will solve that and we will get here 17. But how can override the precedence of this particular multiplication operator over the plus operator? So I can just write down, like I can just write down the brackets here. So when I will just put the bracket, that particular operation will be performed first. So 2 plus 3 multiply 5. So 2 plus 3 will be performed first. We will just get 5, and then this multiplication will just take place, 25. Okay. So these are the certain kind of things, and the, like, the rules which are required for solving the infix expressions. Okay, but in the prefix expression, so this is the prefix expression. So for evaluating the prefix expression, we will just go from right to left basically, here from right to left. Okay, so first we will just there is in just we have two operands here, 5 and 3, and the operator. So what we will do, we will just evaluate them. So the operator which come first, while we are scanning the expression from right to left, we will just solve that. That's very simple. So 5 3 means we just multiply 3 into 5. So we will get here 3 into 5 15. Now this will become a single operand here. So now we have the expression plus 2 15. So the resultant will be 2 plus 15, that is 17. So as you can see here, we need not to check any precedence. We need not to like think about the associativity. We need not to like think about the brackets. We just scan the expression from right to left and we will just solve that. Let's see this one. So when we are just scanning from it from right to left, 5 3 2, so as you can see, this is the operator here. We'll just solve this one. It will be 2 plus 3. Okay, so we'll get here 2 plus 3 5. Now we have multiply 5 5, so we'll perform 5 into 5, that is 25. Okay, very simple. So no parenthesis needed. As in the case of postfix expression, in the same. So like as compared to the prefix expression, we will just go from left to right basically. Okay, so we'll scan this from left to right, 2 3 5 star plus. So I will just tell you in some more videos like how we can just convert the expression from infix notation to postfix notation using the stacks. Okay, so 2 3 5 multiply plus, so we'll just scan it from left to right. So now you can see here 2 3 5 star, so star comes here, so we'll just utilize 2 operand before the star, 3 5. Okay, we will just evaluate them. So 3 5, we will get the result, and 5 3 into 5 15, 2 15 plus. Now we have two operands, one operator, 2 15 plus, so the resultant will be 17. In this case, just go from left to right, 2 3 plus 5 star. So 2 3 plus will be evaluated first. So we'll get here 2 3 plus mean 2 plus 3, that is 5. So then we will resultant will be 5 5 multiply. So the final evaluation will be 5 into 5. So as you can see here, there is no parenthesis needed here either. So the problem with the infix expression is like we are the human being, we are just utilizing them. We can just easily solve them, and we can remember what is the precedence in that. But if we just evaluate the postfix or prefix expression, then very less information we need to store as compared to the infix expression. Okay. So the conclusion here is the infix is the only notation that require parenthesis in order to change the order in which the operations are done. Okay, so that's why it is easy for the system to evaluate the prefix and postfix expression. So here are some precedence rules. In the expression, we will just perform the parenthesis in the prefix expression. Then we will just go for the exponent. Then we will go for the multiply and division. Multiply and division have the same precedence. Okay, so in the case of like we have two operations, multiply and divide in an expression, then both as both have the same precedence, then we will just go with the associativity, means which will come first from left to right, we'll solve that. As same in the case of addition and subtraction, both have the same precedence. Okay, so this is all about the infix expression, postfix expression, and prefix expression and the problem that just occurs in between the like evaluating the infix expression and what are the like simplicity with the postfix and prefix expression. Okay, so now I will just give you some few examples like how we can convert if we are given the infix expression to the postfix and prefix manually. Okay, and in the next video I will just give you the detailed examples for converting the expressions from which are given in the infix form to the postfix form and the prefix form using the stack. Okay, so suppose we have an expression here. I have an expression a plus b. I will just take the simplest example here. Okay, so I have the expression a plus b. This is given in the infix form, and let's suppose I want to convert it in the postfix form. Okay, I want to convert it in the postfix form. So how can I convert? So let's just write down the expression here, a plus b. What we need to do, the rule for converting an operation into the postfix form, the rule is, suppose we have the operand 1, then operator, then operand 2. Okay, so what is the rule here? This is in the infix form. I want to convert it into the postfix form, so I will write here operand 1, then operand 2, and after that the operator. Okay, so this thing we need to just apply here. We have this expression, we have two operands and one operator. So for postfix form, I will write operand 1, operand 2, and the operator. Oh, this is the resultant 1. If I want to convert it in the prefix notation, okay, So I have this example A plus B. So for the prefix, we have the rules. Suppose the expression in the infix form operand 1, operator, operand 2. So in the for converting it into the prefix form, what I will write, just operand 1, operand 2, and I will just place the operator before that. Okay, so let's see here, operand 1, operand 2, and the operator. Very simple. Okay, so in this way we can just convert the expression from infix form to the prefix form and the postfix form. So let's take some bigger examples with the more operands and the operation. Okay, so the whole thing or the whole scenario can be clear to you all. Okay, suppose I have the expression here A plus B minus C like this, and I want to convert it in the postfix form. Okay, so as I am converting it in the postfix form, so that we have three operands here and two operator here. So I have two operator here, so I will just I need to check the precedence here. So here we have the plus, here we have the minus, both have the same precedence. Then we will go with the associativity rules, means which will come first from left to right, that will be solved. Okay, so means we will just solve first this one, then the resultant will be like perform the operation with the next operator operand. Okay, so A plus B. So what is the rule for postfix notation? We will write the first expression operand A, second operand B, and the operator. Very simple. So this will become a single whole operand minus and C. Now we have one operand here, minus, and second operand. So what is the rule? First operand, second operand, and the operator. Very simple. This is the resultant postfix form. And if I want to convert it into the prefix notation, then we can go with the this particular rule. So what is the rule here? The same way, I am just taking the same example here. So we have two operand with the same precedence, then we will go with the associativity rules. So what is the A plus B? So first we'll solve this one, then the another operation. So A plus B means first operand, second operand, and operator will come here. So this is the resultant one for this operation minus C. Now we have two operand plus AB and C and the minus operation. Okay, so we'll write here first operand, second operand, and the operator. So minus plus ABC. As you can see here, AB plus C minus, and here we have minus plus ABC. So this is in the postfix form and this is in the prefix form. So I think hope it is clear to all, like how we can convert the expressions if the expressions are given to us in the infix notation, and how we can just how we can convert them in the postfix form manually. Okay, let me take one more example here so that the whole thing will be clear to you all. We have suppose expression A plus B, and here we have C cap D. Cap is the exponent here, minus E. Okay, so let's see, first we are converting it into the postfix form. So the main difference in between both the two is like we will just place the operator after the operand in the postfix, and we will just place the operator before the operand in the prefix. None other than there is no other difference in between that. Okay, so first suppose I want to convert it into the postfix form. So as you can see, first just we will just read the expression from left to right. A plus B bracket. So I think here multiplication is missing. So we'll just write it multiplication here. C cap D minus E. Now just check here, we have this bracket. So first we will solve this bracket. So we'll write here A plus B multiply, and here how? First operand, second operand, and operator, and minus E. Very simple. Now we have four operands A, B, this one, and three operator plus multiply minus. So over these three operators, multiplication have higher precedence. So we'll just solve this one first. Okay. So we'll have A plus, now here first operand, second operand, and operator. So we'll get the resultant of this operation minus E. Now we have two operators with the same priority, so we'll go with from left to right, means we'll just solve this plus. So A plus B C D cap star and minus E. So we'll solve this one first. Okay, So first operand, then second operand A, B, C, D, cap, star, and the operator. Okay, so we will have the resultant one here minus E. Very simple. Now first operand, and this is the second operand and the minus operator. So first operand A, B, C, D, cap, multiply, plus, and second operand E and the operator minus. So this is the resultant one. So hope it is clear to all, like how we can convert the infix expression to prefix expression and postfix expression. And I think I have cleared the concept of the different notation and what is the basic difference in between them and what is the basically need of prefix and postfix expression over the infix expression. Okay, so thank you all, and let's see you in the next video. We will just convert the expressions which are given in the infix form to the prefix or postfix form using the stack.